Hi class, before we learn about what is the Process Capability Index, which is the core of this chapter, let us do some short revision regarding the content of previous video. As discussed in the last video, we knew that the process capability refers to the ability of a process to produce the product or provide the service capable to meeting the specification of the customer or designer. Variation affect the process of producing the product to meet the customer specification. As a variance source of the variations, which is 4M1E, which will influence the variation of your process. Reducing the natural and assignable causes which may to increase the process capability. This is a short revision regarding the previous video. Today, we will continue this video with how to calculate the process capability index and process performance index. Thus, then, before we go to the calculation part, we have to know why we need to study the process capability index. First, the process capability index will give the information about the process behavior. That means you will understand what is your process behavior. Is it whether can produce a good lot or not? Can meet the specification of your customer or not? This is, you know, how the process behavior look like the crystal ball as mentioned in the previous chapter. Then next, you will know how the reliability can affect the process. Then you understand how to control the variables in your process. Lastly, you can determine the best operating condition by calculating the process capability index. That means you can set your process until a maximum, optimum setting so that each time can produce a good product at the end of the process. Process capability is the natural reproducibility of the process outcome. So your process capability is measure how well the process is currently behaving with respect to the output specification. Therefore, you need to know how to measure the output of your process. The frequencies of defective product can be measured in percentage, part per million, part per billion. The value for your control output, that means the black dot here, is measured in percentage, part per million, and part per billion. Okay. Then you know how to measure the output. Then we can go for the process capability index. The process capability index, as shown in this slide, indicate that the consistency of your process. That means CP/CPK is measure your consistency of your process. Or you can measure the output quality by using ppm and percentage of rejections. Or you can compare with other process we have same setting with current process. This is a three method we can use it to measure the process capability. However, in this chapter we will learn about the CP/CPK only because we need to analyze the variations of the process so your process can be improved rather than you only concentrate on the output only. So this is our focus for today. As mentioned before, the magic ball, which is the control chart for process capability index, is the main tool used to evaluate whether a process is or is not in the statistical control. The control limit is the powerful voice of the process used to identify the special cause of the variations. That means in control chart need to have the UCL, LCL. UCL and LCL is the voice of the process. That means this is a process. How well your process is based on the control limit, UCL and LCL, lower and upper limit of your process. If your output data is between UCL and LCL, that means your process is under control and is very stable. So if a process is stable, so you can predict the product produced from the process is very stable and predictable. If it's unstable, that means the process is not predictable, then it always have the defect at the end of the process. Normally, through the control chart, we can say that this process is out of control when we notice some outlier here, out of control, that means out of UCL and LCL, that is abnormal, considered as assignable causes. So we have to solve it by improvement plan, as you learn in chapter 8. So if in only up and down between the UCL and LCL we consider as a natural causes, so your process considered as a stable conditions can produce a good product. Beside the UCL and LCL, another important limit is the specification limit, which provided by the customer. Also considered as a voice of the customer, are used to determine the product, whether the product meet a customer requirement. This is a control chart for process UCL and LCL limit and upper specification limit from the customer. You will notice that the tolerance for the process is smaller than the tolerance from the customer. That means your process will fulfill the requirement for the customer. If you want to fulfill the requirement from the process and fulfill the requirement from the customer, you have to use the Process Capability Index, CP, formula to calculate it so that you can monitor your process in order to produce a good quality materials. Before we using this formula to calculate the process capability, you have to know the fundamental knowledge regarding this, how to find the sigma. How to find the sigma from here, 6 sigma here. This 6 sigma represents the process tolerance. The 6 sigma normally we use the standard deviations or range to calculate the sigma. The coefficient here you can find through the table here, which you highlight in yellow. C4 is for standard deviation, D2 is for range. Try to do this example to find the standard deviation for this sample set through this formula. As we know that the CP is customer tolerance divided the process tolerance 6 sigma. So the index for this capability will illustrate in 3 cases. First case. Case 1 is when your process tolerance lower than the customer tolerance. So that means the 6 sigma of the process shown by the solid line. This one is the line. This is the customer tolerance. Customer tolerance, your process tolerance is between the USL and LSL. That means this is a capable process. The value still within the specification limit. This allows more room for process shift away staying within the specification. That means your process tolerance is between your customer tolerance. So your process is capable to produce your customer requirement. For example, your customer required 2 cm is the upper specification limit. Lower specification limit is 1 mm. Your process always produce the data is 1.5 until 1.8. So your tolerance for your process is within the tolerance of the customer. That means your process is capable to produce the requirements based on the customer. Okay, so your process is capable for case 1. Case 2, when your the process tolerance is equal to the customer specification. Then your process is equal to that. That means this is the ideal condition. Your process is very optimum. That means no need so much improvement. It is very optimum, win-win station. No any lose from any party, customer and the producer. So this is the ideal condition. You can produce within the spec of the customer. Case 3 is when your process tolerance is bigger than the customer tolerance. This is your process customer tolerance target here, customer tolerance here. Your process tolerance is out of the specification limit. That means this is undesirable conditions. This is not capable. That means it's incapable to meet the customer specifications because the tolerance of the process is bigger than the customer tolerance. So this is not the desired condition. Please bear in mind how to evaluate your process is based on these 3 criteria. Next, we will go to the example of potential capability index CP. How to calculate the CP? This is an example. So this is a case for GE Insurance claim process based on the claim time. Process mean is 210. The mean time, the process sigma is 0.156 minutes. The design specification to meet the customer is 210 plus minus 3 minutes, which is the upper limit is 213 minutes. Lower limit is 207. It's very straightforward. The specification limit tolerance is 213 minus 207. Then the process tolerance is 6 times 0.516 equal to 1.938. What is meant by 1.938? 1.938, that means your tolerance, upper tolerance here is bigger than the process tolerance. So if you break in the pictures, bigger than CP is more than 1, that means just now you get 1.938. That means your customer requirement is this one. Your customer requirements is this range. Your process tolerance range is here. So your tolerance is within the limit of the customer. So this is the desired condition. This is the case 1. This is the case 2, where the CP is equal to 1. That means the tolerance of your customer is equal to the process tolerance. Customer specifications is same with the process. This is the ideal condition. That means save time, save cost. Then the next is the case C3. Your customer requirements is narrower than your process tolerance. This is not capable one. How about this one? This is the shifting from the customer requirement, which is covered in the CPK. I will cover this condition in next video. Thank you for that. I hope you understand well what is CP first, then how to calculate it in 3 conditions. Thank you for that.